Hey guys, welcome back to chemistry. Today we're going to be talking about Lewis structures for ionic compounds. So you've learned how to draw a Lewis structure. Now we're going to talk more specifically about how these Lewis structures behave in ionic compounds or ionic bonds. So there's two different kinds of compounds in nature. There's covalent and ionic, and we've talked about these before, but now we're going to get into more detail about them. Ionic compounds are made of both metals and nonmetals, and covalent compounds are made up of only nonmetals. So remember on the periodic table that there is a jagged stair-step line on the right-hand side of the periodic table, and everything to the left of that jagged line is a metal, and everything to the right of it is a nonmetal plus hydrogen. Now let's look at table salt, or NaCl. Sodium chloride. This is an ionic compound, and that's because sodium is a metal and chlorine is a nonmetal. So why do these elements come together and make a molecule? Well, let's look specifically at their Lewis structures. So sodium is in column 1A. It only has one valence electron, so there's only going to be one dot on the outside of Na. For chlorine, it is in column 7A, so it is going to have 7 valence electrons on the outside of it. Notice that chlorine structure is actually pretty close to the ideal valence electron configuration. Remember that the ideal valence electron configuration is to have 8 total electrons around the outside. So chlorine only needs one more to have 8. And sodium just happens to have one valence electron. So chlorine could reach the ideal electron configuration if it could just take or steal that one electron from sodium and make that electron its own. So let's see what happens if it does this. So, sodium's going to give away its electron to chlorine. Well, when sodium gives away its electron to chlorine, it's losing an electron, and it also reaches the ideal electron configuration because it loses an electron and it doesn't have any around it. Chlorine gains an electron, and so it's going to have the ideal electron configuration. Now, when an element is giving away an electron, it's losing one negative charge. So sodium is going to have a positive charge overall because when you lose something that's more negative, you're becoming more positive. So it loses one electron, it has a plus charge now. For chlorine, it gained an electron. So since it gained an electron, it is going to be a 1 minus charge on the outside of it because since it's gaining one more electron, it's gaining one more negative charge. So in ionic compounds, nonmetals tried to gain electrons so that their Lewis structure has 8 dots around it. And once a nonmetal's Lewis structure contains 8 dots, it has the ideal electron configuration and will be stable. Hydrogen is the exception to this. When hydrogen is part of an ionic compound, it gains an electron to get 2 dots in its Lewis structure, not 8. So hydrogen only wants 2 dots. But what about sodium? Once it loses its electron, it also has the ideal electron configuration. So sodium's original electron configuration is this here. But when it loses an electron, sodium will only have 10 electrons left and not 11. So its new electron configuration is 1s squared, 2s squared, 2p to the 6. We got rid of that 3s1 because it lost an electron. And this is the same electron configuration as neon, which is an ideal electron configuration. So, in ionic compounds, Metals try to lose electrons until their Lewis structure has no dots around it. And nonmetals try to gain electrons, and metals try to lose electrons. So atoms will join together in such a way as to make sure that they all end up with ideal electron configurations. When a sodium atom loses an electron, it ends up with 11 protons and 10 electrons. Thus, it has more positive charges than negative charges, and this gives it an overall positive charge of 1 plus, or you could just write plus. When a chlorine atom gains an electron, it ends up with 17 protons and 18 electrons, and this gives it an overall charge of 1 minus, or you could have just put minus. So this is explaining what we just did before. So when an atom gives up or gains one or more electrons to become electrically charged, we refer to it as an ion. And an ion is an atom that has gained or lost electrons and thus has become electrically charged. So looking back at our example with sodium and chlorine, when sodium gave away its electron, it became an ion because all of a sudden it gained a charge. Because when it gave away an electron, it became a 1 plus charge, so it became an ion. Same with chlorine. Chlorine gained an electron, so it gained a 1 minus charge and thus became an ion. Now, positive ions have the same name as the atom from which they came, and negative ions have an IDE suffix added to the name of the atom from which they came. So since table salt is made up of a sodium ion and a chloride ion, we call it sodium chloride. Okay, so let's look at a bit more difficult example. Let's look at the ionic compound that's formed between magnesium and fluorine. So we have the two Lewis structures for magnesium and fluorine here. Magnesium has 2 electrons around it, and fluorine has 7. Now, since the fluorine atom has 7 valence electrons, it must gain 1 more to attain the ideal electron configuration of having 8 around it. So the fluorine atom is going to take 1 of these electrons away from magnesium. But even though fluorine has the ideal electron configuration now, the magnesium does not, right? Because it took 1 away from magnesium, it became ideal, but magnesium still has 1 left over. So, in order to get no dots in magnesium's Lewis structure, we need to give that last electron away. But fluorine already has all the electrons it wants, so it won't take magnesium's last electron. However, there are, most likely, other fluorine atoms around. Thus, another fluorine atom could come up and take magnesium's last electron. So what we did here is we just added another fluorine atom, and that other fluorine atom is going to want to take the other electron away from magnesium. So when it does that, both of magnesium's electrons are going away to the 2 different fluorines, and the fluorines are gaining electrons. And when that happens, fluorine becomes a 1 minus charge. Magnesium becomes a 2 plus charge since it's giving away 2 electrons. And this other fluorine has a 1 minus charge. But each of these now have their ideal electron configurations. Okay, so since it took 2 fluorines to gain the electrons and 1 magnesium to lose them, the chemical formula is MgF2 because there's 1 magnesium, but there's 2 fluorines. And this is where we're going to stop today. We'll continue on with this tomorrow. Talk to you guys later.